Until now, the world has only looked at the headlines. On January 3rd, the Venezuelan government collapsed. The president was captured. From a distance, it looked like a standard military operation, swift, decisive, and successful. But if you strip away the propaganda and look at the raw technical data, the physics of that night don't make sense. Not at first. Consider the S-300 missile batteries protecting Caracas. These are not relics, they are Russian-engineered masterpieces designed to intercept hypersonic targets at 100,000 feet with a 98% probability of kill. They represent billions of dollars in defensive investment. Yet as 150 American aircraft flooded the Venezuelan sky, these systems didn't just fail to fire, they didn't even wake up. They sat in the darkness, radars, spinning missiles armed, completely silent, while the government they were meant to protect was dismantled around them. This wasn't a victory of courage over fear, it was a mathematical impossibility. How does a 12,000-ton cargo ship drifting innocently offshore hijack the nervous system of an entire nation? How do you convince a veteran radar operator that an armada of strike fighters is nothing more than a passing weather pattern? And how do you land a heavy-lift helicopter in the heart of a hostile capital without triggering a single sensor? The news told you what happened. They focused on the operators on the ground, the Delta teams, the silent professionals. And they were indeed flawless. But in the realm of advanced systems engineering, the goal is to make heroism unnecessary. The objective is to turn a suicide mission into a standard repeatable procedure. Today we look past the soldiers. We are going to reverse engineer the invisible architecture that turned the deadliest airspace in South America into a controlled laboratory environment. The first problem was not tactical, it was systemic. How do you penetrate heavily defended airspace without triggering anomaly detection protocols? The conventional answer is stealth aircraft, the F-22, the B-2. But the math says otherwise. The US inventory does not contain enough stealth platforms to sustain a high-intensity 6-hour operation of this scale. The vulnerability therefore wasn't in the visibility of the aircraft, it was in the data processing architecture of the enemy. Radar does not see an airplane, it generates electromagnetic reflection data. That data must then be transmitted through a communication network, processed by software, and finally interpreted by a human operator. Each of these steps creates a failure point. The US Navy didn't try to hide the signal. We hijacked the processing chain itself. The center of this digital storm was 200 kilometers offshore, the MV Ocean Trader. To any passing observer or satellite, she was a Panamanian registered bulk carrier deep in the water with a manifest of bauxite ore. In reality, her internal configuration housed 400 kilowatts of signals intelligence processing capacity. The Venezuelan military communications network operates across 287 distinct radio frequencies. The Ocean Trader didn't just listen. It decrypted 50,000 simultaneous transmissions in real time. A ratio of 174 to 1 overwatch. This was not mere surveillance. This was the construction of a digital twin. For 3 weeks leading up to the strike, the system analyzed every transmission pattern, every command hierarchy, and every millisecond of decision-making latency. By the evening of January 2nd, US Cyber Command didn't just know where the enemy was, they possessed the complete network topology and the psychological response patterns of every individual operator in the chain. But signals are only half the story. You need visual confirmation to close the loop. High above the capital, the RQ-170 Sentinel, the beast of Kandahar, loitered in total silence. Its thermal sensors mapped physical movements inside the Miraflores Palace, correlating every radio burst with a physical action on the ground. The system didn't just hear the command structure, it watched it breathe. Once the neural network of the defense was mapped, the operation shifted from observation to active suppression. Physical systems require physics-based solutions. 6 EA-18 G Growler aircraft established a perfect hexagonal formation around Caracas, each hovering exactly 180 kilometers from the city center. Each was equipped with AN/ALQ 99 tactical jamming systems, generating 10,000 watts of directional radio frequency energy. Here is the physics problem. The engagement range of an S-300 VM is 200 kilometers. By positioning at 180 kilometers, the Growlers place themselves inside the effective suppression range, but outside the missile's optimal engagement envelope. The Growlers didn't seek to destroy the radar. They created an electromagnetic white noise dome. Imagine a person trying to see in a dark room only to have a high-intensity spotlight shone directly into their eyes. The radar remains functional, the hardware is intact, but the visual system is saturated. Calculate the asymmetry of this moment. Venezuela invested $2.1 billion into their S-300 batteries over 8 years. 6 Growlers with a total acquisition cost of $420 million rendered that multi-billion-dollar investment operationally worthless in exactly 90 minutes. This is systems engineering warfare. It is not about expenditure superiority, it is about calculation superiority. By 2:15 hours, the Venezuelan military had entered a state of sensory isolation. Their radars were functional but blinded by spectrum saturation. Their communication links were active but monitored and mapped. Their command loops were severed by interference. The result was a cognitive lobotomy. The sensors were operational, the weapons were ready, but the threat perception capability was reduced to zero. This is the ultimate transformation in modern conflict, moving from the destruction of capability to the absolute control of perception. The airspace was now a void waiting to be filled, but the mission was only beginning. The kinetic threats remained mobile batteries, fighter jets, and the human element. The system had achieved silence. Now it had to maintain it. The silence was a canvas, but the canvas was still dangerous. Venezuela retained significant kinetic capability. 23 Su-30 Mk-2 fighters across 3 air bases, mobile S-300 batteries with the ability to relocate, and Book M2 short-range systems forming a dense ring around the capital. The second system's problem was neutralizing this air defense without a massive bombardment. Traditional military doctrine dictates destruction, bomb the runways, eliminate the aircraft in their hangars, and accept the collateral damage. But the constraints of this mission were absolute. Civilian casualties near air bases would mean international condemnation and a failure of the mission's moral logic. The alternative calculation: don't destroy the weapons. Make their deployment mathematically impossible. We started with the fighter problem. The Su-30 Mk-2 is a formidable interceptor with a combat radius of 1,500 kilometers. A single pilot getting airborne could destroy the extraction helicopters and end the mission. But an aircraft is only as dangerous as the surface it sits on. At 2:15 hours, 2 B-1B Lancer bombers orbiting 370 kilometers offshore released a volley of AGM-158 JASSM standoff missiles. The target wasn't the planes, it was the geometry of the runways at La Carlota, Barquisimeto and Maracay. Consider the runway denial mathematics. An Su-30 requires a minimum of 550 meters of clean runway for a combat-loaded takeoff. The GASSM delivers a 450 kg penetrator warhead. The physics of the impact creates a crater 12 meters in diameter and 4 meters deep. By placing just 3 impacts per runway, you create 36 meters of disrupted concrete at critical intervals. The runway isn't gone, it is simply unusable. The aircraft cannot achieve takeoff velocity. By the time the Air Force commanders realized their wheels were trapped on the ground, the US extraction force already had a 40-minute head start on their 98-minute flight profile. The temporal window closed before the enemy even reached for the door. Next came the mobile missiles. S-300 batteries are designed to shoot and scoot, moving every few hours to avoid detection. Here the F-35 Lightning II transformed the equation. The F-35 is not just a fighter, it is a distributed sensor node. Its AN/APG-81 radar scanned the spectrum, sharing data instantly with every ship and aircraft in the theater. Venezuelan operators faced a lethal dilemma. If they activated their radar to search for the Americans, they would broadcast their exact coordinates to the network. If they stayed silent, they were blind. 3 batteries chose to fight. Within 90 seconds of their first emission, they were engaged by AGM-88, G-Advanced Anti-Radiation Guided Missiles AAR-GM-ER. These missiles don't just home in on a signal, they use terrain constraint modeling and electromagnetic pattern analysis to predict where the radar is, even if the operator turns it off in a panic. The average flight time to impact was 87 seconds. We didn't eliminate every battery. We only engaged those threatening the flight corridor. The remaining batteries stayed operational but chose never to activate. This is deterrence through demonstrated precision. The weapon you convince the enemy not to use is more valuable than a pile of burning scrap metal. Then there were the F-22 Raptors. while the F-35s mapped the ground, the Raptors enforced the sky. With a radar cross-section equivalent to a marble, the F-22 is invisible to Venezuelan radar beyond 20 kilometers, yet it can track multiple targets at 200 kilometers. The Raptors established a presence enforcement barrier. When Venezuelan pilots attempted to scramble from secondary civilian strips, they didn't hear a human voice on the radio. Instead, their cockpit warning system suddenly screamed. They were being painted by a firing solution from an empty sky. The psychological calculation was absolute. The pilot looks at his radar, it's empty. His survival instinct looks at the warning light, he's about to die. Training says fight, survival says land. Every single aircraft returned to base. Zero kinetic engagement was required to clear the air. At 30,000 feet, the E-2 Hawkeye acted as the battlefield conductor, fusing the data from 150 assets into a single crystal clear tactical picture. While the enemy saw a chaotic blur of noise and ghosts, the Americans saw a synchronized ballet. Calculate the system efficiency. Venezuela's defensive investment totaled roughly $4.3 billion. The US countered with 2 bombers, 4 Raptors and 12 F-35s. The total cost of munitions expended was $14 million. The asymmetry is staggering. A $4.3 billion capability was neutralized by a $14 million precision geometry in just 27 minutes. We didn't outspend them, we outcalculated them. By 2:42 the airspace belonged to the United States. Now it was time to move into the streets of Caracas. The airspace was secured, but the mission now moved from the vacuum of the sky into the density of the city. This was the third systems problem, executing a capture operation in a high-density urban environment with a constraint of 0 collateral casualties. The target was at the Miraflores Palace. To the south sat a hospital, on 3 sides were residential blocks. The palace was guarded by security forces, equipped with armored vehicles. Traditional doctrine would accept civilian casualties as an operational cost. Here the requirement wasn't just to minimize damage, it was to eliminate it. To solve this, we had to address 2 physics problems: neutralizing armor without explosive overpressure and extracting the target within a 5-minute window. First, the armored vehicle problem. Venezuelan security had deployed 3 Chinese-made CS/VP 4 armored personnel carriers to block the extraction routes. These vehicles had to be removed to clear the landing zone for the MH-47 Chinook. The solution was the MH-60M Direct Action Penetrator, DAP. This is not a transport helicopter, it is a flying tank. It was configured with an M230 30mm chain gun firing, high explosive dual purpose HEDP ammunition. Consider the physics of blast containment. Each 30mm round has a muzzle velocity of 805 meters per second. The round is designed to penetrate the 12mm vehicle armor and then detonate inside the crew compartment. The vehicle's own hull acts as a containment vessel, absorbing the shockwave and fragmentation. From a range of 800 meters, the DAP engaged. In 14 seconds, all 3 vehicles were neutralized. Because the kinetic energy was contained within the armor geometry, a residential building just 10 meters away suffered 0 overpressure. This is the definition of surgical maximum effect on the target 0 propagation beyond the target. With the perimeter secured, the armored bus of the operation moved in. The MH-47G Chinook is a massive machine, 22,000 kilograms of mass when loaded with Delta operators and the target. Landing this in a cramped palace courtyard in total darkness, surrounded by 3-story structures, requires more than skill. It requires perfect spatial awareness. The 161st Special Operations Aviation Regiment SOAR executed the breach. Ground time less than 5 minutes. The target was secured, the operators reboarded and the pilots engaged maximum lift. The aircraft hoisted that massive weight, vertically clearing the rooftops by inches. But how was this entire symphony? The cyber attacks, the jamming, the precision strikes, and the extraction coordinated across 150 aircraft and 12 warships, without a single communication error. The answer lay 380 kilometers offshore. The USS Gerald R. Ford is not merely a ship. It is a floating data processing center that happens to launch aircraft. Its primary advantage is tempo. Traditional carriers use steam catapults with 4-minute recharge cycles. The Ford uses the Electromagnetic Aircraft Launch System, EMALS. It functions like a linear motor using magnetic fields to accelerate a jet to 170 miles per hour in 2 seconds. It recharges in 45 seconds. Calculate the tempo advantage. A traditional carrier hits a maximum of 15 aircraft per hour. The Ford can theoretically push 80. On January 3rd, the battle network maintained over 90 aircraft airborne for 6 continuous hours. While Venezuelan pilots were stuck on the ground, American pilots were already redeployed. We imposed a tempo the enemy physically could not sustain. Supporting the Ford were 4 Arleigh Burke-class destroyers in a diamond formation, creating a redundant radar screen. Every cubic meter of airspace was monitored by at least 2 radars simultaneously. To the west, the USS Iwo Jima sat just 200 kilometers from the coast, serving as a forward base for the helicopters. This positioning was mathematically optimal, close enough for a 67-minute flight to the capital, yet far enough to remain outside the enemy's anti-ship missile envelope. By 0433, the Chinook touched down on the Iwo Jima. The target was in custody. All aircraft were recovered. The system had functioned at 100% efficiency. History tells us that war is chaos, loud, messy, and unpredictable. But what happened in Venezuela proved that history can be rewritten. This wasn't a battle, it was a physics demonstration. We dismantled a government protected by billions of dollars in hardware without even waking up the seats. This is the new definition of power. It isn't about how much explosive tonnage you can drop, it's about how perfectly you can arrange the variables. While the enemy relied on courage, we relied on geometry. We didn't just defeat an army, we defeated the very concept of luck. From 380 kilometers away, the algorithm didn't just predict the future, it manufactured it.